Honestly, I don't know. I have to check, to be honest. All right, let's do some stuff. Okay, so we went through all those formulas and all that stuff, right? Well, we never have to do that again, really, but I can use those formulas now to effectively start proving everything, and then we don't have to write as much to. You're all right, Beyonce? Calm down, come on. So all right, so you crazy person. Wait, let's just go over the schedule real quick because there's some things I want to discuss real quick fast. Um, so what do we have over here? All right, 1023, supposedly exam 4 is supposed to be due. I'm gonna make it due a little bit later than that. I'm gonna make it due probably the 28th. Okay, that's Saturday. All right. Um, but this exam will be due on this particular day. We will not be changing this date here. Does everybody see that? So what I am going to do though is because there's a couple people who've had some issues with number of things, to be honest. And I figured, I think what I'm going to do is I'm going to make this exam 4 also cumulative. Does that understand what I'm saying? So it's going to be on chapters 1 through 6, the way it's labeled here. Does that understand? All right. And then what I'm actually going to do is I'm going to extend exam 3 a little bit further. Some people didn't do it. I don't know why. Okay. Um, some people I do know why, obviously. But the so there's gonna be an extension for some of these things online, but this will be our last shot. Does that understand what I'm saying? All right. So that's it. Okay. Now though, because I'm going to extend this, okay, I can't go and replace the exam scores with exam 3 if I do so. Does that make sense? So I'm gonna have to use exam 4. Does that understand? All right, so I'm still gonna do it, okay? But I'm not gonna replace your exam 3 score once you take it. Does that make sense? So exam 4 can substitute for exams 1 and exam 2. Does that understand? I told you I was gonna substitute those previously. Is that correct? All right. Again, the real reason why we're doing this is just to try to encourage people to, because you do reasonably well on this exam 4. There's maybe 30% of the material left in the class. Okay. It's sort of impossible that the person would do well on that exam and then tell me they would not be able to do the stuff on the final. It's the same crap. Does that make sense? There's more on the final because we haven't finished everything, obviously. But but that shouldn't really be the biggest issue. Does that make sense? All right. So what I think I'm going to do is I think I'm going to allow you to replace exam 1 and exam 2 scores with what you got on exam 4. All right. If your exam 4 is higher, obviously, I'm not going to lower your grade. All right. And then exam 3, I'm going to provide an extension effectively. And I'm also going to reopen the homework assignments. Now, if you don't do these homework assignments, these are supposed to be more or less like 3 points. I can't do anything for you if you don't do them. Does that understand what I'm saying? All right. But you will have the opportunity to redo them now. Okay. If you had an issue before. All right. Okay. Again, like this is sort of just a trick by a teacher. I'm just getting you to do your work anyway. Right. Okay. But I feel like you have a reason to do it because you do well on this exam and your score is going to dramatically increase. Does that make sense? Now, mind you, you're still going to have to pass the final in class. Again, we've said this multiple times recently. You're still gonna have to pass the final again in class. You do need to use the calculator, right? Because you're not gonna have a computer here. Does that make sense? Right? So please, please, please be practicing with the calculator. That's why we're going over it in class. All right. Any questions? All right. So I'll do that probably by tomorrow. The changes you'll see online. All right. Any questions about anything? All right. I do this grade replacement stuff from time to time, but I have to tell you, I never usually extend anything. Does everybody understand what I'm saying? All right. So please take this opportunity and use it. All right. If you need it. Sorry. They're just pretty. I'll take that, right? So no, I think you can do it. I think you can do it. And if you do it a day late, as long as it's not a day late at the end of the semester, we're kind of okay. Does that make sense? Right? But the thing is if I can get you to participate and I can get you to keep going, you have a chance of finishing this thing, right? And that's the point. Okay. So so that's what I mean. It's a trick, sort of. There's really a second chance, right? But I think when there's actually a point behind some of these things, then all of a sudden maybe some people will find the reason. All right, what do we got here? It says find the mean of this thing. How would you do that? Put in the calculator, type this in L1, type this in L2, and then just do one bar stats. Is that correct? All right, how would you do this one here? It says find the standard deviation. Do the same thing as correct. Type this into, now just let's remember, like we always have to distinguish between the values and the frequencies here. Does that make sense? Right? All right, we did this one already, so that's not too exciting. We did this one. We did these. I don't think we did this one. A 28-year-old man pays $181 for a life insurance policy with a coverage of $150,000. The probability that he will live through the year is 0.994. What's the expected value for the policy? So the values and their respective frequencies here. He pays $181. That means, well, excuse me. There's two types of outcomes here that we could sort of have happen here. If it's a life insurance policy, the person could live, or I guess they could die, right? If they live, then they're going to lose this money. Does that make sense? If they die, that means that they're going to receive the coverage value from the policy. Does that make sense? Now, the only thing is it's not clear here whether or not the person is going to get their $181 back also or not. Does that make sense? I would just assume they're not going to. So I'll subtract 181. So in other words, if they pass away, whoever is going to receive the money from this policy, we're saying they paid out $181 and then they would receive $150,000. Does that make sense? They got 149,000, whatever. Does that make sense? The probability this person is going to live is 0.9994. The probability they would pass away then would be 0.0006. Does that make sense? Compliments. And all we would really have to do again to do this is, so you have to be able to write this out, but then you just type this in L1 and L2 and do one bar stats again. Does that make sense? Question here? How do you find the value of the insurance policy? I don't understand. Expected value. So what's expected value mean? What does expected value mean? You don't remember what it means. That's a problem. It means average. It means average, yeah. The expected value is the average value. We said that like probably 30 times. All right. But You got to remember these things. Otherwise, you're going to tell me you don't know how to answer the question. Does that make sense? That's what I was saying. It's not clear. Does that make sense? We did this one. Weird. We must have done this one before. We did this one. Is this the same worksheet? Probability. We did this. We did this. I don't believe we did these. Yes, I did. I did one of these. This was just using the mean and standard deviation from the binomial distribution. Do you remember the formula? What is it? Because you have to know the formula for the final also. I told you this before. And for all the remaining exams now.
No, just repeat it. Repeat it.
What is the question talking about? Well, you need the mean and the standard deviation, right? So what were the formulas? Mean was n times p is correct. NPQ is correct. Good. All right. I'm just reminding you because again, you need to know this formula. Does that make sense? All right. Question? This is all over your homeworks and stuff. All right. So all right. So this is another chapter now. Okay. All right. So let's go over this. So this, I think, is chapter 6 now. Chapter 6 is sort of about now continuous distributions. N times P. Continuous distributions. One of the main things about this chapter is the normal distribution. And we also talk about this thing, which is the main point of this whole class, the central limit theorem. All right. Let's see if I can remember what this chapter is about. All right. So then there's something that they call now a density curve. Oh, can someone make a distinction first between discrete and continuous distributions? The last chapter was about discrete. This chapter is continuous. What's the difference between those two things? Give me an example or something. To some extent, yes. You have to be slightly more specific. Just because of the fact that I can give you an example where I can't see the difference then between the two, the way you just said it. Between what? Yeah, that's true. So like over continuous is like something that occurs over an interval of values. All right. So like I could say that like the average height, well, not average height, just the height. Okay. Average height sort of works too, but just height. We haven't really talked about how average stuff works exactly. That's part of this chapter also. But if you say like how many dollar bills could a person have in their wallet, right? It could be one, it could be two, it could be three, it could be four, it could be five, it could be six, it could be seven, it could be eight. I mean, like, it really could be any number, really. Is that correct? It doesn't really stop. Does that make sense? Right? But it's still called discrete because you can't have like 1.5. You can't have all the numbers between 1 and 2. Does that make sense? All right. So then all right. So previously when we were talking about like all these probability distributions, we talked about, so for instance, like if I do a binomial probability distribution, it'd probably look something like, let's say like this. Here's an example of some type. Okay. But when we talk about continuous distribution, like that's not going to work anymore. because we can't just say there's like 0, 1, 2, 3, 4, 5, whatever. Does that make sense? It has to be all these numbers between those values as well. Is that correct? So the first example that they start talking about is this thing. So what I'm trying to say, I guess I should mention what the density curve thing first is. If we were trying to graph something that would relate to the probabilities here, but it's not exactly that, so I don't want to really write that. And then if we had a function that we can use that would describe, let's say these are all the values of x. Does that make sense? And then this is sort of something related to like how often the value can occur. Does that make sense? Right. So an example, this particular shape that I'm drawing here, this one's called a uniform distribution. So we say xi is UAB if x is uniformly distributed over the interval AB. This means all values from A to B are equally likely. Does that make sense? Uniform? Does that make sense? All right, so an example. I remember these things like I don't know, they're sort of like called like spinners. Like you play like a game, like one of these board games or something like that. And it has this like wheel like thing. And then they put these numbers or something. And then there's like a little, you know, just like a little thing and you kind of like flick it or whatever and it goes around. Does that make sense? Does that make sense? Yeah, just a wheel, but that thing like spins around and it lands on a number or some nonsense, right? So it's like supposedly a random way to to give you these numbers. Does that make sense? Um, but like let's pretend like if it was gonna land over here, then this number here would be like 1.470123417892 blah 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 blah. Does that make sense? All right. In other words, my point is we can hit all the decimals. Does that make sense? Does that make sense? All right. Then I asked, tell me what the density function is. So how do we write this? So it's like we have any possibility from like 0 to 8. Is that correct? Right? But then I don't, assuming this thing is completely random and like each of these things has the same chance of occurrence because we're just flicking it, right? Then I don't know what this would be here, but I know it would have to be flat. They'd have to be the same chance. Does that make sense? Does that make sense? Yeah, we could say that the result of the spinner is uniformly distributed over the interval 0, 8, I guess. Does that make sense? Does that make sense? All right, now, why are we talking about this density curve stuff? Well, first of all, we're going to have to talk about one very soon, which is the normal distribution. Right? We said before that that was really important and stuff like that, and I told you it was going to come back up. Does that make sense? Right, what was it? 68, 95, 99.7, right? So then I want you to imagine like what this means and how this stuff works. Okay. With a bunch of monkeys throwing darts. All right. Pretend I have like an infinite supply of darts and monkeys who will throw the darts. Okay. Then they're not good at throwing darts. They don't know nothing about darts. They don't listen to you. They laugh at you. I don't know if you've ever interacted with monkeys before, like actual real monkeys, but they're sometimes extremely feisty animals. Like they throw their excrement at you. Like you stare at them, and you think they're not paying attention to you. Next thing you know, it takes a little, just chucks it at you, you know? And yeah, my dad used to have one. So told me, oh, yeah, my dad used to live in Africa. So the he says it's the most gorgeous place in the entire world, and all the places that he wants me to go to, we can't go to anymore because you know. So my cousins used to live in Zimbabwe, and they got chased out of Zimbabwe to London. I thought I might have mentioned this to you, but their dog's head was cut off in their front lawn because these rebels, um, took over, and that was the end of. That was the last time they were ever in Zimbabwe. But I'm just writing a U, just a regular U. Well, it doesn't really matter. You can just write however you want, but it's just U. So then we have these monkeys, right? So they got all these darts, okay? And I'm gonna be like, throw the darts, okay? Now let's pretend. So this is just a graph of one of these typical type of distribution functions, all right? Let's pretend again these monkeys start throwing these darts, and I wanted to know what the probability was that again this is like X here. I want to know what the probability it was between, let's say, A and B. What's the chances that you get some number between A and B? Does that make sense? All right. What's the matter? You all right? You'll understand. There's a theorem. I don't make this stuff up. I can't. I'm not that intelligent. But there's a theorem. It's called the infinite monkey theorem. What? What you got? Look, I'm not making it up. Here, see, infinite monkey theorem. Okay. So I didn't make up this idea. It's just this is a way to think about this stuff. A lot of books write it this way, so I think it kind of makes sense. But what's your question? Actually, I don't even want to know. I think I gotta say I'm a little scared. So like wait, just imagine this. All right, so you got these monkeys that are throwing all these darts. Okay, every time the monkey throws the darts outside of this thing, I'm not gonna count them. Does that make sense? But if the monkey throws the darts inside, we're gonna count them and we're gonna leave the dart. Does everybody understand? This is not exactly the infinite monkey theorem, but it's the same idea. It's calculating different probability. All right. So this now you imagine these guys just keep throwing these darts forever. Okay. So eventually this would like sort of like be covered. It's like no more place for darts anymore. Does that make sense? And there's no more place for darts over here anymore. Does that understand what I'm saying? And then if I wanted to, the way I would start trying to calculate the probability of something between, let's say, A and B. I don't know. How would you use the darts to do this? What would you do? How would you estimate the probability of something between A and B if it had to follow this particular curve and stuff like that, given all these darts? What would you do? You could do that, but that's not what I want. I'm talking about darts. Simple. How would you estimate the probability of some value being between A and B? Well, yeah, but Much simpler than that. How would I do it based off the darts I'm talking about here? Huh? Yeah, count them. Count what? Which darts? And that's it? How would that give me a probability? So I'm gonna get like 10 billion darts. Then what am I gonna do? Oh, thank you. So like I'm gonna count the number of darts that are gonna be between A and B. Is that correct? And I'm gonna take that and divide by the total number of the darts that were thrown. Is that right? Does that make sense? But like the only reason why I'm saying this is because I'm trying to make sure that you understand why everything here has to do with area. Really, a simpler way to do that would be just to find the area between A and B. Is that correct? And then divide it by the total area. Because eventually the whole thing's going to be covered anyway. Is that correct? So the yellow area divided by the total area. Is that right? Well, probability distributions have some property about the total thing. What do we know about the total for all the stuff in the probability distribution stuff we talked about before? What do we know about that? Must add up to 100%. Is that correct? So if we want this thing to have some sort of representation about, probability or whatever, right? Then the total thing, the total area should add up to 1. So the total area for any probability distribution under the graph must equal to 100% or 1. In other words, this part is always 1. So really, every time it's just the area between A and B. Does that make sense? Does that make sense? All right. Now let's go back to our uniform distribution here. I remember we were talking about here the spinner thing, right? Flick this thing. Does that make sense? All right. What if I wanted to know? Well, first of all, what is this height here? What is that value? How would I determine what that value is? I don't know, let's call it P. How do I determine P? What would you say? What'd you say? Where do you get 9? One divided by 8. Why? No. No. I mean, it's related to that, but it's not correct based off what I'm writing here. What's the only thing I've pretty much said about density curves so far? There's only one thing I've said really. That was for a uniform density function. I'm talking about this thing. What did I just say right here? Whoops. Right here. Total area is equal to 1. And then the probability of some specific events or set of events or whatever is really the area under the curve between those events. Is that correct? Is that correct? Mm-hmm. So how am I going to use that here? Sorry? Why? Why do you got divided by 8? What do you mean? So the area of the rectangle, right? Is equal to what? Length times width. Is that correct? What's the length in this case? 8. What's the width? P. So then this should equal to 1. Is that correct? So then P should equal to 1/8. Is that right? So this number right here is, whoops, 1/8. All right. Now let's ask some question. What's the probability I get between 1.5 and 3.75? How would I figure this out? Mm-mm. So if the numbers are uniformly distributed between 0 and 8, how am I going to say what the chances I'm going to get between 1.5 and 3.75? I mean, you got to keep going. Doesn't sound great so far, to be honest, but it doesn't mean you're wrong, depending on what you do afterwards. So what are you going to say after that? Try and use the idea of the area stuff than what we're talking about here, because there's no other way you can calculate these things. So it has to be something about the area under the curve, right? But the height's all the same. Is that correct? I mean, you tell me you want to calculate this area here, I think it's kind of hard. You want to calculate some area over here, I don't think it's that bad. Does that make sense? So what are we going to do? Something about that you're going to have to do, but what are you going to do with it? Yeah. All right. Now, let's pretend like 1.5 is right here, 3.75. Let's pretend it's like over there somewhere. So in other words, we want to know what's the chances we get somewhere between here and here. Is that correct? Does that make sense? Which is like 1.5 is there, 3.75 is there. It's the same thing. It's just a different picture. Does everybody understand what I'm saying? But the second picture that we're having here, these are the ones that you guys have to come up with. Does everybody understand? So first you have to understand it's uniformly distributed, right? Then after that, you just have to state what the two values are that are here and here, whatever they happen to be. And then you have to be able to figure out what that one is. Does that make sense? Now, how am I going to find the chances now that the probability of this value of this variable is going to be between whatever I just said here, 1.5 and 3.75? What will we do? I'd find the distance between here and here, 3.75 minus 1.5. That's what you said before, right? So this is 2.25. Does that make sense? And then just multiply by the height. Does that make sense? Does that make sense? 1/8. So this is 3.75 minus 1.5 times 1/8. 2.25 is what? 9/4? 9/4 times 1/8 is 9/32. Does that make sense? Does that make sense? Of course, we could just do this on our calculator also. 3.75 minus, what did I say? 1.5. About 28% or whatever. Does that make sense? Does that make sense, guys? Should be fairly easy. Is that right? 28% that something would be between here and here, given the situation. But the point is that now all of a sudden it becomes about these area things. We've mentioned this before a number of times actually, but we haven't had to do it. Does that make sense? All right. But do you get why, if the monkeys were throwing the darts, if you started saying that there's more chance you get these values right here, there should be more darts the monkeys could throw below it. Is that correct? Than this one over here. Does that make sense? So there have to be more darts there, right? Higher chance. Does that make sense? But we're just trying to say the darts because I'm trying to represent the total coverage of the area. Does that make sense? Question here? You understand what I mean by density curve? All right, so what does this guy say? He has this one. What's the probability the value is greater than 1 point? I'm going to go with 3. That's so weird. Like the worksheet is printed on the computer. I don't understand how that's messed up. It's not like this was scanned. Oh, it's my dumb program. That's why. Yeah, anyway, whatever. Okay, so then this OneNote, when I printed into OneNote, it got messed up. The 1.3, how would I do this? That's correct. So 1.3 is like over here somewhere, right? So the probability that X is going to be greater than, see, greater. Also, I should have mentioned this before also. Given any continuous distribution, um, what is the probability or the probability that the random variable equals one value? So you have a continuous distribution. I want to know what the probability is that it's going to be one number. In other words, I want to know the probability that your height is exactly 6 feet tall. I just wanted one number. I don't care what number you pick. Does that make sense? So you can consider a uniform distribution if you want. That's the one we talked about a little bit so far. I'm asking now, what's the probability? So I don't know. We can even use the example we were just talking about. Like this was 0 and this was 8, right? This is 0.125. And I say, what's the probability we get this number here? I don't know. Let's say it's 1.7. What would your answer be? Nope. So you're saying is like, okay, wait, we got to think about how bad these answers are first. No, because otherwise you're not gonna understand why there's a problem. Does that make sense? All right. So the what did you say first? You said 1.7 times 0.125. There's no way we can multiply this value times the probability because this is just one value. They should all have the same chance. Is that correct? We said they're uniform. Is that right? So now you're telling me if I had picked 0, I'm going to do 0 times 0.125. And if I pick 8, I'm going to do 8 times 0.125. That means they're not having the same value. So that's no good. Does that make sense? Okay. What did you say? You said 1/8, right? 1/8. Okay. Now for sure, like if I could draw, one of those regions would have chance 1/8. Is that correct? Not one number, though. One number. Does that make sense? There's no way you can tell me just that one number has 1/8 chance because there's actually what? An infinite amount of numbers here. Is that right? Now, if I took an infinite amount of numbers and I multiplied that times 1/8, we would still get infinity. The area needs to be 1. Does that make sense? Do you understand what I'm saying? There's no way one number could have the chance of 1/8. There's an infinite amount of them. The probability would be way bigger than 1 for the whole thing. Does that make sense? Is that correct? So what does the answer have to be? If there's an infinite amount of possibilities here. Is that correct? You get 0, 0.1, 0.01, 0.001, 0.0001, 0.00, whatever. You can just keep going here. Is that correct? Right? There's way too many numbers here. I can't even list them. Does that make sense? Like I wouldn't even know where to start. What's the smallest one? 0. What's the next one? I can't even write it. 0, 0, 0, 0. But how many zeros? I don't know. Does that make sense? Right? You can't list it. Is that correct? Okay, but for sure, there's an infinite amount of values there. Is that right? Is that right? So the probability of getting 1.7 would have to be like 1 out of infinity is correct. Does that make sense? Which is what? What does that mean now? Think about it though. If you take 1, you divide by a really big number. It's going to be very small. It's going to be very small. Is that correct? It's going to be 0, actually. But like, how many times can infinity fit into 1, right? Or if you took 1 and you broke it up into infinite amount of parts, how large would that part be? It would have to be like size 0. Does that make sense? Does that make sense? The probability of any one given event when it's a continuous distribution is equal to 0. Because if you think about it, the area of that line is 0. Is that correct? What's the width? 0. Is that right? It would have to be 0 times 0.125 or whatever. And we get 0. Is that correct? Line does not have area. Is that right? Does that make sense, guys? Question? Does that make sense? For any continuous distribution. So the reason why I was bringing this up is I was asking this question before. What's the probability your height is going to be 6 feet tall? The answer is 0. There has never been a person on this planet, or there never will be probably, who will ever have a height that's exactly 6 feet. It is so impossible, it's not even funny. Because we have 6 point, it needs 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. I need an infinite amount of zeros here. What's the chances that's going to happen? At least one of those numbers is going to be different. Does that make sense? And we won't even be able to tell the difference anyway, right? Does that make sense? All right. So there's probably never been a person on the entire planet, and there probably never will be, who will ever have anything. We probably never made a length of wood, anything that's been exactly 6 feet long. Does that make sense? Exactly, even, I can't even say, it's so many decimals. You can never measure it. Does that make sense? Yep. Temperature doesn't even like make any sense when you think about it, because like temperature is about like all these particles, and then these particles, like they say in chemistry that when you have a mole of particles, there's 6.02 times 10 to the 23rd particles. That's a lot. Okay. So then there's some amount, right? 6.02 times 10 to the 23rd. Well, each of those particles has different energy associated with them. They're not all the same, right? They could have an average energy that's very close, but there's a distribution of actual energies. All right. And then when we talk about temperature, we really start discussing the average of all of these things. Does that make sense? All right. So then what does each one have? Does that make sense? Okay. You get what I mean though with this? All right. You understand it has to be zero? Does everybody understand why? If it's not zero, then it would add up to way too much. Does that make sense? So this is a weird thing in calculus, all right? That if you do like infinity times zero, we don't know what it means. You have to do more stuff. Sometimes it's zero, sometimes it's infinity, sometimes it's some number between zero and infinity. Does that make sense? Sometimes it makes no sense. You can't even do it. All right. So the point is when stuff like that happens, it's just like you have to do a little bit more math. You have to figure out what it actually means or whatever. But in this case, I think this should make sense so far. Does that make sense? All right. So let's get to our normal distribution. Question? Money? All right. Hopefully you start realizing now. I'm sure you realize a little bit from the previous homework assignment that the calculator was pretty helpful, or the StatCrunch or whatever and stuff like that. But you got to be able to do this stuff on the calculator, as we've mentioned. And you're going to see very shortly now. And I'm telling you, I'm very good at calculus. I am not calculating some of these things. It's not happening. Like it would take me like a day and a half to do like one question. Okay? You need these things. Does everybody understand what I'm saying? It's more important, honestly, if you know how to do this in the calculator, the crap that I know how to do. All right? So somebody had to come up with it a long time ago. Great. I know what someone came up with a long time ago. But you need to know how to do it and do it quickly. All right? So the only thing that we talked about previously with the normal distribution was the 68, 95, 99.7. We really didn't talk about very much else. Does anybody remember what that meant again? Good. That's correct. So I guess I might as well leave it. Oh, that's what I wanted more on. All right. This shape is the shape of a normal distribution. We did it a long time ago. I started saying something like, this thing, like this area here, we said was about 60. What the shit? That's not good. 1 over square root of pi. 2. What did I do? 2 over square root of pi? That was right. Square root of 2. Okay. Sorry, this is being dumb. All right, 68% of the area approximately falls between here and here. Does that make sense? We did this before. Then we said like when it was 2, it was 95%. Then we said it was 3, and it ended up being 99.7%. Is that correct? Right? Well, we don't just need those values. We need a lot more than just that. Does that make sense? Like, what if it was like 1.3 to 4.7 or something? Does that make sense? So we need to be able to calculate this stuff. All right. Well, first of all, it's extremely easy on the calculator. Second of all, you have to do it like for everything. All right, so let's say I want to calculate this in this first case here. This is the probability, I guess, that Z is going to be between -1 and 1. This is the probability that Z is going to be between -2 and 2. This is the probability that Z is going to be between -3 and 3. I told you a long time ago, I said there was something we need to remember about Z-score. I said people were going to forget it, but I said we have to remember this. What does Z-score mean again? It's X minus mu over sigma, we said. What does it mean? What does that mean? I mean, okay, the score on the test, yeah, sure, but it doesn't have to just be about tests, right? It could be about heights or something. Is that correct? What is that? What does this mean? I mean, I could subtract and divide and stuff like that, but I need to know if you know what it means. That's correct. Good. The number of standard deviations away from the mean. Negative means to the left, positive means to the right. Does that make sense? Does that make sense? All right. Z. Z is sort of like special also. So if I say xi is normally distributed, we said this before, I believe also, but is normally distributed with mean, mu, and standard deviation sigma, then what I will write is this, xi, n, and then I'll write the mean here and the standard deviation there, like this. Does that make sense? Because we need to state what the mean and standard deviation are for normal distribution for us to actually be able to calculate anything. The mean tells us where the center is. Standard deviation starts telling us how spread out it is. Does that make sense? That's all we need, the mean and the standard deviation. And then it turns out they're going to have to tell you that in the questions because you're not going to be able to sit there and figure those parts out. It's not like you know what the mean height of the women are or something like that. They have to tell you. Is that correct? So it's just reading to find those things. All right, but then they have another one. They call it the standard normal distribution. We call it Z. We say Z is normally distributed with mean equal to 0 and standard deviation equal to 1. Does anybody remember why we say anything like that from what we talked about from the last class? We said something like this. Z is equal to x minus mu over sigma if the expectation of x is equal to mu, and if the variance of x is equal to sigma squared. Then what we said is that the expectation of Z is the same thing as the expectation of x minus the mean over sigma. This is a constant, so we could take this out. The mean is not random. In other words, this part is simply the mean here. But the expectation of x we're assuming to be the mean as well. Therefore, it must be 0. The average value of the z-scores must be 0. 0. Is that correct? The variance of x minus mu over sigma. When this comes out now, we have to make sure we square it. Mu is not random. Does that make sense? So if I just subtract a number from all of the numbers, I don't really make them vary more. Does that make sense? The spread doesn't change. So this is actually the same thing as just the variance of x to start off with. The variance of x we assume to be sigma squared. Therefore, we get 1. Does that make sense? And this ends up being true for any distribution the minute that you have a mean and a standard variance. The minute these things have some values, you do z-score, the average z-score is going to be 0, the variance of the z-score is going to be 1, which would then imply that the standard deviation is 1. Does that make sense? So they refer to it as, and it's the simplest possible one you could come up with. Does that make sense? Centered at 0, standard deviation is 1. Does that make sense? Simplest numbers. All right. So then we call this a standard normal distribution. Does that make sense? Turns out every single normal distribution can be explained in terms of a standard normal distribution. Let's see if we can calculate some stuff. All right. Where do you think I'm going to go to calculate this stuff? What button? Yes. That is correct. Second vars, because it's distribution, we have to click on distor. So we click second vars distor, right? Now, where do you think we're going to go? Which one do you think we should pick? Why would it not be PDF? PDF is exact, right? We already know the probability of getting exactly one thing. Is that correct? Also, PDF would end up telling us like the height at like one of these places here. That's not really going to help us. Does that make sense? We need CDF. Does that make sense? Right. Like a range. Does that make sense? All right. Now, you got to be a little careful with some of this stuff. I'll explain in a second. All right. First thing we need to know is what this means. So if they start saying like 1E99, does anybody know what this means? Mm-hmm. But we need to know exactly what it means, okay? So like 1 times 10 to the power of 99, okay? Don't worry about it. Well, I'm just saying, once you understand what this means, it'll be fine, okay? So like, in other words, if I wrote like 6E4, this would be 6 times 10 to the power of 4, or this would be 6 times 10 to the power of 4, just means move the decimal place four places over. Is that correct? 1, 2, 3, 4, whatever. Does that make sense? Does that make sense? So if I write 6E negative 4, this means 6 times 10 to the power of negative 4. This means really 6 times 1 over 10 to the 4th. You're dividing by it now. Moves the other way. Does that make sense? So this would be 0.1236. Does that make sense? Does that make sense? So one just means moving one way, one means moving the other way. So if they write this in the calculator, what does it mean? Yeah. Well, tell me what number. I don't know what that is. What is? I don't know what that statement says. I'm asking you what this number is. 99 decimal points to the left. What the heck does that mean? Behind the one. I don't know what you mean by behind. In front of behind. I don't know what you mean. Like, what is it? Is it a big number, a small number? I don't know what you guys. Big number. Okay, finally. That's really all I'm looking for. Does that make sense? But the thing is you have one, and then it's just like, whoa, right? Right? And then you're saying there's 99 zeros there. Is that correct? Is that what you're saying? All right, that's good. That's all it means. Okay. But that's like a huge number. Okay. The calculator is only going to have like space up to 99 always. Does that make sense? So this is like one of the biggest numbers we can write in the calculator. Does that make sense? Like we could write like 9.99999999999 whatever times 10 to the power of 99. That would be the biggest one, I guess. Okay. This is almost the biggest number in the calculator. Does that make sense? All right. So you put a negative in front of it. Now it's almost the smallest possible number that you could plug in. Does that make sense? Now, if you have a normal distribution, the thing is over here is really like negative infinity, and over there is positive infinity. We can't obviously type infinity in the calculator. Does that make sense? So then we type these things to sort of represent like really, really big or infinity. Does that make sense? Like this is like sort of like positive infinity, and then negative infinity is sort of like -1 times 10 to the power of 99. Okay. Now, if you go on the calculator first, I should say this before we start doing any of this crap. How would you do this? How do you type in the EE crap? By the way, all calculators work like this. All right, even those like $5 ones, they all work like this. Because the screen only has so many digits and you need more. All right. So this EE thing here, second comma, does everybody see that? Second comma. So if I write like 5 and then I click second comma and then I push 4, it's going to give me this thing. Does that make sense? So it says EE there, but that's how you type the E. Does that make sense? Hello. All right. So then if we go to distr and we go to normal CDF, this is going to be really easy now. So when doing normal CDF, so if xi is normally distributed with mean, mu, and standard deviation sigma, actually, first let's do standard normal. So if this is standard normal, does everybody see that? So that means the mean is 0. If I want to find the probability between A and B, all I do is normal CDF, A comma B. Does that make sense? Does that make sense? So in the calculator, it'll be calling this your lower, and it'll be calling that your upper. Okay? So if I want to calculate this one here, first one, what would I type in the calculator? I would type in -1 here. Now remember also, please look up here for 1 second. This thing right here, that's the negative. Does everybody remember this? Not this one. Does everybody understand? All right. -1, 1, mean zero, standard deviation 1, because it's standard normal. The calculator assumes it that way. Does that make sense? So then I push paste. It gives me this. Does everybody see that? I'm just going to delete these two parts here. Does everybody see that? And we get the answer. Does that make sense? 68%. Does everybody see that? Now, if I come here and I do between 2 and 2, what should we get approximately? Should be somewhere around 95%. And we get 95.45. Does everybody see that? Does everybody understand what I'm doing here, guys? Typing in the lower and upper numbers here. Does that make sense? Don't worry about it. You'll see. All right. Trust me, learn it the way I'm saying it. It'll be much simpler. All right. People. Okay, this is another thing. You go to the math lab, they're not really going to understand what to do with this to teach you properly. All they know how to do is to do the questions. They don't understand what they're doing. They don't understand why they're doing it in a lot of cases. All right. There's a relationship here that you're supposed to understand between the standard normal distribution and all the other ones. So I'm going to explain that. Does that make sense? All right. But I didn't make the calculator. They made it work this way. Does that make sense? They're trying to teach you something. You get what I'm saying? Okay. So all I'm really doing in here is typing the lower z-score and the upper z-score. Is that correct? Does that make sense? That's why we always need these z-score things. And it's extremely important to understand z-score because we're going to need it for chapter 7, chapter 8, chapter 9, all of them. Does that make sense? There's going to be a simple way that we can type all of this crap in the calculator. I'm going to show you. But I recommend learning it the way I'm saying it. Otherwise, you're going to get confused in the next 3 chapters. Okay? I'm going to show you both ways. But there's a reason why they programmed the calculator this way to teach people something. Does that make sense? All right? I'll explain when we get to it. All right? First, we're going to do stuff with standard normal distributions. Then we'll talk about non-standard normal distributions. Okay? So we don't need the mean and the standard deviation here because the mean and the standard deviation, the calculator is already going to know it's 0 and 1. Does that make sense? You don't write it, it's going to say it's 0 and 1. Does that make sense? It's like the default. Okay? Question? The only reason why I'm saying it this way is because it gets confusing. If you go watch a video somewhere or you see something else, you'll be like, why is he saying it differently? This part that gets confusing. All right. Because it says 0 and 1. So it's assuming there's 0 and 1, but you change them to different numbers, it's going to change. If you don't write 0 and 1, it's assuming it's 0 and 1. All right. But the point that I'm trying to say is that if the calculator was programmed this way, why would they do that? You know what I mean? And then it turns out most programs are all programmed this way. Also, there's something that's referred to as they call it an overloaded function. I really want to get to this afterwards. I really don't want to talk about this right now. But they call it an overloaded function. Overloaded function, what that means is that there's multiple ways you can type stuff in. And it gives you different answers depending on the way you type stuff in. So it turns out you can type in stuff. You can type in 1 number. You can type in 2 numbers. You could type in 2 numbers and a mean. You could type in 2 numbers, a mean, and a standard deviation. And each thing has a different meaning. Does that make sense? Slightly. But we're going to go over it. Does that make sense? All right, you get how to calculate it, though. It's pretty simple, right? All you do is type in the but z-scores particularly. Does that make sense? Lower and upper z-scores is correct. Does that make sense? Right? If you were going to program it, wouldn't you make it work that way? You have to tell me what the lower and the upper are, otherwise how the hell am I going to do it? Is that correct? Once you tell me that, I should be able to tell you the answer, right? Question? Yeah, right. So do this one then. Now assume this is shaded all the way to the left. Now just remember again, if we're going to pick the number on the left here, it needs to be -1 E99. Does that make sense? What am I going to type in here to get the answer in this case? How am I going to find the probability that Z is less than or equal to 1.13? What am I going to type in? Come on. No, because like, okay, so this is hard to read here, but they intend actually for this to keep going. Like it keeps going and going and going. Yeah, that's right. Yeah, it's negative infinity is correct. Does that make sense? All right. So I want to try and make sure that we know how to type this thing in because that's not all, you don't usually type in numbers like this. Does that make sense? Right. -1, then the E was what? The second comma, right? Then the 99. Does that make sense? And then we need to go up to 1.13 is correct. Does that make sense? Did you guys get it? That's correct. That's correct. What did you guys get? Now, another thing is that we have to be able to, so that's correct. Usually they want to 4 decimal places, so then they're gonna want 0.8708, I guess. Does everybody see that? Does that make sense? The only problem is that you kind of have to still remember a little bit about what we learned earlier to see if you're ever typing the stuff in wrong. Okay. So what we had said was that it was like 68% from here to here. Is that correct? Well, half of 68% is what? 34? Yep. Then this part right over here from here to here would have to be 50. Is that correct? So that's like 84% all of this stuff. And what do we get? 87. Yeah, it makes sense. Does everybody see what I'm talking about? Question with that? That's the only way you're going to be able to estimate these things, though, using the empirical rule. Does everybody understand? Or by trying to draw the picture and just like trying to eyeball it. Does that make sense? All right, what about this one? How do we do this one? Yeah, but so what are we? We're at 1E99. Is that correct? All right, so then second dister, whatever, normal CDF 0.591 E. You should be telling me though that like you like the calculator now. Okay, like this you should be telling me you're like, oh, this is not too bad to do it this way. The thing I like about it though is that I swear to God, if I show you how to do it in Excel, it's the same thing. If I show you how to do it in a programming language, it's the same thing. Does that make sense? Relax. 0.2776. All right. Does this make sense? What about this one? Tell me what the answer is. Yeah, but I mean, I need to know what the the result is. I want to know if you got the answer correct. Sounds about right, because it has to be a little bit less than 68%. Does everybody see that? Does everybody see why it has to be a little bit less than 68%? Because if you don't see that part, there are some issues with respect to some of the other concepts. You need to be able to tell me that this is less than the area from -1 to 1. Is that correct? No, just like -1 to 1 is like here and here. It has to be more area, right? So if that's 68, this has to be a little less than 68. Does that make sense? What do you mean you think so? No, come on. Like that means you don't. That means you don't. No, it has nothing to do with that. Like this. Look, this is -1. This is 1, right? So if I say the area from -1 to 1, the gray area is smaller. So it has to be less than 68%. I think that's what it said. 0.6424. Which of course is the same thing as 64.24% or whatever, right? All right. Find the indicated z-score of the graph depicts standard normal distribution from mean 0 to standard deviation 1. Shaded area is this. They mean really the shaded area to the left. Just keep going this way again. Does that make sense? So this particular shaded area is 0.9599, they're saying. Does that make sense? Almost 96% or whatever. Does everybody see that? Question? The area there, he's saying, is about 96% of the total area. The gray part, yep. Definitely not. Wait. That mistake you just made is a mistake we need to discuss. Because every single person in here is going to make that same mistake. Okay? And it's extremely important that, first of all, we know we're all going to make that mistake. Okay? And that we can somehow distinguish between what we need to distinguish. Okay? So I honestly didn't expect anybody to say it yet. You shouldn't be making this mistake right now yet. Okay? But the values or z-scores, they're going here. Is that correct? There's some area that we talk about or probability, but that's the area, right? Does that make sense? So is this a value? You must always distinguish between the values and the probabilities. Does that make sense? Values go on the bottom, the probabilities go inside. It gets confusing, honestly, sometimes. Does that make sense? Like it can be very obvious to you, and then all of a sudden you don't look at it for a little while, and then you start looking at it and you're like, I don't know. Then you think about it and you're like, wait a second. That doesn't make any sense. I can't take the probability and say it's right there because it needs to go to infinity. Does that make sense? You understand what I'm saying about that? Question? We have not talked about how to do this yet. So the normal CDF function, we'd have to do it by trial and error to get this answer, and it would take forever. Does that make sense? We just keep plugging numbers and guessing. Does that make sense? All right. So we need another way to do it, right? So the thing is when we had normal CDF was taking a lower z-score and an upper z-score, and then it was giving us a probability or area. Is that correct? Is that correct? Now, though, we have like a probability or area, and we are either asking for the z-score or the value. Does that make sense? Before we were asking for probability and area, now we're asking for this thing. Is that right? So this is like x goes to y, but then this would be like y is coming from which x. Does that make sense? Does anybody know what that's called in math? Inverse. This is sometimes referred to as a function, right? And then this is, if this one we want it to be, we call it the inverse function if that's a function as well. But does that make sense? Sometimes people write like f, and then they write f like that, inverse. Does that make sense? Just means go backwards though. Like you have the y, you want to go backwards. Does that make sense? All right. The bottom line, I need another function, right? It's not like you just sit here and you're like, oh, if you square something, then square root's gonna undo that. Like that's not just like obvious. Does that make sense? All right. Like all you do in algebra 2 is talk about these inverse functions or college algebra. The log and exponential function, those are inverses of each other. Does that make sense? All right. This one's too confusing though. Like this is not simple. Does that make sense? I can't just go give you a function. If I write it out for you, you'll tell me you're even more angry. All right. We don't want to come up with the function. We don't want to write it out, log and all this stuff. Does that make sense? All we want to do is use the calculator to do it. Well, there's going to be a nice way to do it in the calculator. So there's something that's called invnorm. Invnorm expects the area to the left. What's the matter, bro? I got a little neck problem. That's all. It's got a little neck. All right. So the no, but I hope you're realizing a little bit why I make this stupid joke, because the stupid calculator requires you to write this to the left stuff, and we have to remember that. Does that make sense? All right. So if there's a position here, right? This position, so let's say we say that there's some area to the left, or percentage, or percentile. Does that make sense? So for instance, like, I don't know, 88%, right? For example. Does that make sense? Well, this position right here would then be P88. Is that correct? It's the position that has 88% of the data less than it. Is that right? All right. Well, the way you do this in the calculator is you just type invnorm, and then Beyonce says to the left. So you say 88% is to the left. Does that make sense? You tell it the amount to the left, it'll tell you what the value is. You tell me the other amount to the left, it'll tell you the next value. Does that make sense? So in this case, the z-score associated with this particular position is, all I do is second dister. You'll see this one says invnorm here, inverse, right? It goes backwards. Does that make sense? Then it starts asking me for area. Does everybody see that? Second dister number 3. Again, we don't need any of this crap here. Does that make sense? Does everybody see that? I'm not writing any of that stuff. Just that. Does everybody see that? And now it tells me the area to the left of this stuff. I'm just warning you, if you don't pay attention to what I'm doing and you keep writing all this extra stuff, it will start causing you issues because you won't understand what it means. Yep. Uh-huh. Only wrote just what I'm writing on the board. Does that make sense? That's all it really needs. Plus it's simpler then. Does that make sense? Question? You tell it the area to the left of some position, it's going to tell you the z-score of that position. Does that make sense? %, 0.88. You can delete all that. It doesn't make any difference. Well, excuse me, it can make a difference, but just delete it for now.
Right. So
that's another reason why I'm not going over it. A bunch of people's calculators won't actually say it. All right. And I don't really think the ones in the lab say it either. So that's another thing. All right. Question? Yeah, but just do it the way I'm doing it. It's fine. Yep. Yep. But you got to remember which function it is, right? We're almost done. I got a new class starting. Feel bad. Their class is it's the same class you're taking, but it's session 4, and it's only an hour, 2 hours and 30 minutes a week. So it's an hour and 15 minutes tonight, and it's an hour and 15 minutes on Thursday, and that's it. And it's just really fast, and it's sorry. Honestly, it wouldn't be much different. The only way it might be different is if they don't go over the stuff. There's a lot of teachers that don't go over anything. You can find teachers that are literally going to just give you an A. Well, you have to do something, but I don't know, what it really is. Do you get what I'm saying? There's a lot of teachers like that. Okay, like you can find them. They don't skip chapters. They just make. We're not done yet, guys. I don't know what you guys are doing. But that's just because that guy walked in. I don't think you understand why you think we're done. But you want to go. But but I'm not done yet. But but they'll when they give the test, maybe they make it like so easy that you won't have to understand. Maybe they give people projects that the people will cheat on that they don't even grade. Stuff like that. You know what I'm saying? Maybe they make the homeworks worth like 40, 50% of your grade. And then the people flunk the test and then they still pass anyway. No, high school statistics there's a lot more stuff in there. That I believe. Okay. That I believe. I unfortunately believe you. And that's not your fault at all. Like but the thing is like it sells you guys short because then sometimes people have to come here and pay for it, right? It wastes your time, you know what I mean? And like I got benefit from these things by some stupid teacher who actually forced me to do it when I was in high school, And then the thing that's screwed up about it is the teacher who taught me when I was in high school, fresh out of college, first year, all right? He graduated. I went to Stoneman Douglas in Coral Springs, the place where that shooting happened or whatever. And then sorry? Oh, really? I went to Stoneman Douglas or whatever, obviously well before the shooting ended up happening or something like that. But I have a terrible story about that shooting if you ever want to hear it. But that we're not gonna do it today though. But the amount of people that I saw that went to that school that didn't learn statistics the year before I took statistics was like practically everybody. Then the next year we get this guy, he comes to the school. He used to go to Stoneman Douglas. He went to UCF. And he had gotten some degree from there or something like that. And he couldn't get a job, was trying to find a job. And so they let him work at the school there because, I guess he had a good relationship with the people from the school or something like that. And then so he was a teacher for that 1 year. And every single kid who took the AP exam that year passed. And I remember learning like a bunch of stuff in that class. And it was very helpful for me for all these years later on. And I think I told you the story, like I did materials engineering and these people like didn't know any statistics and all they had to do was these research experiments all the time. And it was really hard for everybody. So it was very helpful to me when I did it. So that's the reason why I'm teaching you these things this way, because he's the way he taught it to me. And like, if I ever had to do the things later on, it was very helpful, all right? But some people have never taken another statistics class. So how can they do that? Does that make sense? So all they really try to do is just make sure some people can answer some of these questions and then they move on. And that's a way to do it. There's, it's good for some people, depending on what you're looking for. But the thing is like I have students that go into supply chain management here at this school. There's more statistics classes that they have to take. I teach those classes and we have people not passing them. You know what I mean? And it's because of the fact that they're coming into some of these classes and then they're not being really taught properly. And then I have students that come from Nova Southeastern to this school after they've already taken statistics at Nova Southeastern and paid all this money for it. And then they tell me that they can't pass the class at FAU or FIU and they have to come here, try it again. Wow. I can't believe that that's actually the school I just mentioned. But the high school is not the same as the university though. Okay. I mean, the same ownership, but it's not the same thing. All right. How would we do this question now that I just babbled? How would I find this position right here now? Yep. We would just do 1 minus 0.0694, and then we would get excuse me, 0.9306, right? And I would just do inv norm of 0.9306. Is that correct? Does that make sense? Because the area to the left is 1 minus this, right? If it's 6.94 to that side, then it has to be 93.06% on this side. Is that correct? It's because they're complements, right? Right. Previous question? Well, the calculator expects in here area to the left. So this is not the area to the left of the position. This is the area to the right. All right, then they start saying there's a critical z-score for area alpha. All right, they label this z alpha. Okay, so z alpha is like this position with alpha being the area to the right. This is the only time in the whole class they ever mention anything to the right. All right, how do I calculate this? Z alpha, this is inverse norm. Then all I would have to do is figure out what's on this side. Well, if this is alpha, that has to be 1 minus alpha. All right, I think this is the next question or something right here. So it says like z.005. Does everybody see that? You see it? Well, I just want to label it first. Oh, there's another thing I made a mistake today. All right. I should be mentioning to you that you should constantly be attempting to write these normal distributions out. Does everybody understand what I'm saying? For multiple reasons. One, it reinforces all this crap over and over and over again. You get used to writing them out, and then there's less to remember. Does that make sense? Two, it helps you estimate the areas. So you can know if you're kind of making a mistake when you type something in. Does that make sense? And sometimes just by writing it down with the multiple choice and stuff like that, you'll actually be able to get the answer. Does that make sense? All right. It's very important you keep writing them down. Does that understand what I'm saying? We'll do it more next class anyway, but does that make sense? All right. So I'm just going to do this one real quick, 25. So again, just try and write these things down. Remember when they say this thing here, it means area to the right in this case. Does that make sense? So I label this over here as 0.005. Does that make sense? Then I need to find out what that position is right here, what the z-score of that is, right? So z of 0.005 is going to equal to, okay, we know we have to do inv norm now. Does that make sense? Inv norm of what? 0.995, good. This side would have to be 99.5%, right? Because the whole thing has to add up to 1, right? Does that make sense? Is that correct, guys? All right, how would you do the next one here? Or the last one, I should say? That's the last one, right?
I don't know, Eric, is this- like,
It'll calculate it for you. Calculator. So that's another thing. I should have said that also. We haven't done a lot of these calculations yet. Usually this first worksheet is like the simple one. So then I don't really get into all this yet. But like if I want to do this one here, right? 0.36. This damn thing is a calculator, right? It's gonna do it for you. Does that make sense? So like you just need to type it in correctly, right? That's all I want. That's all I want. Does that make sense what I'm saying? So then, well, not even. Look, you come here, right? You go to this, and you do 1 minus 0.36. Now, again, though, I'm using this minus here now. Does that make sense? Right? This, we don't even need to. It'll give you the same answer, okay? But it'll do it for you. Does that make sense? Okay? So what does this mean? 0.35, what does it say here? 0.3585. This means it's approximately 0.3585 standard deviations to the right of the mean. Does that make sense? But for any normal distribution, it wouldn't matter what it is. Okay. So in other words, another thing we're saying here, I just want to make sure, because again, this gets a little bit confusing. See, this one's asking for the 40th percentile here. You have to do in norm of 0.4. Does that make sense? All right. This number here, 1 minus 0.36 is what? 64%, right? This is the 64th percentile. The 64th percentile for any normal distribution, it doesn't matter which one it is 0.3585 approximately. Does that make sense? Does that make sense? All right, but this stuff is not so bad. Does everybody understand? That's why I like doing this now and letting people make up with this test. First of all, it's a lot of the material, right? We have to know it anyway. Does that make sense? This is a good time to go back and work on some of the old probability stuff if that's the stuff you're having difficulty with. I told you that's the stuff that people have problems with, but this stuff's easier. Does that make sense? Does that make sense, guys? Now, also another thing, your calculator, I sort of consider it like your toolbox. You go into the construction site, right? If I have a screwdriver and a hammer, even if the job is not supposed to be using a screwdriver and a hammer, my ass is going to use a screwdriver and a hammer because that's all I got. Does that make sense? Right? Your calculator is your toolbox that you're bringing to the construction site. You have these functions in there, right? 1 var stats, binom PDF, binom CDF, normal CDF, inverse norm. Does that make sense? All you really have to do is, which tool do I need? Does that make sense? And make sure that you know how to use it. Does that understand? Okay. All right, one more thing. I think I put this thing online. Or if I didn't, I'll do it right now. Oops. I did this, okay? Where I just put all the videos on YouTube in order. Does everybody understand what I'm saying? All the ones from this class. Does everybody understand? I'm gonna keep adding them. I just put it on there. I just made one just for this, honestly. I never uploaded a video before. This is the first time I've ever uploaded a video to YouTube. But the sorry? Well, that's why I'm doing it. Because first of all, some people start telling me that they can't find the videos, which you should be able to find the videos, honestly, because some of your other teachers are going to do it the same way. Sorry, we're not done yet. 1 second. So we'll be done in a second though. This thing here, if we, but I think this will just be easier. You know, maybe you can load it from your phone or something like that. So anyway, I'm going to post this online right now somewhere for you. Yo, me calling your ass Beyonce is on YouTube. Should be more worried about that. So like no, I'm kidding. God only knows what's on YouTube. All right. But actually, unfortunately, God probably knows what's on YouTube. But this, I don't know. I just feel like it'll be easier for you guys to watch it this way. Also, you'll be happy to know that this is, there are no charges, so there shouldn't be ads. Okay. So if you do see ads, let me know because I'm gonna go call Google and be like, "Yo, bitch." No, I'm not gonna ask them for the money because I have to make an account and all this crap like that. And I don't want the money, honestly. It's like 5 seconds. But the point is like if I'm not charging for it, they shouldn't be putting ads on there. You get what I'm saying? So like that's what I'm saying. All right, anyway, but if you come on here and you go to this thing, hopefully this works now. You go to whatever it says, this thing, okay? And then it says YouTube video playlist. Now again, please remember, I do not have access to the video that we just did yet, right? It will not allow me to publish it. If you see here, this is not today's video. Does everybody see that? It has to compile. Does that make sense? Once it compiles, then I can download it and put it on Zoom for you and put it on the YouTube thing. Does that make sense? All right. So that's still going to take like a day or two or something like that each time. Does that make sense? All right. All right. That is all. Thank you, guys.